are I/O, input and output connectivity, but they're not locked down to anything. And I've got 4 bits of general purpose I/O. Those are pins you can turn on and off at will, and they're not tied to anything specific.
So that'll give us your basic blink.
It'll let you blink LEDs, it'll let you run LED strings, it'll let you do actually quite a lot of functionality if you want to do lower level programming.
Now, can you run a software PWM out of one of those?
You could, in theory. It would be very, very slow. I wouldn't advise it. I am going to provide some functionality for doing some things with PWM that won't be done in software.
Okay. So that'll be some hardware PWMs. That's something that excites me a lot because I always run out of PWMs on every dev board, on every project, and end up eating into my microcontroller space with software PWMs and other pieces like that aren't optimal.
Now I've got 4 uncommitted analog ins, and these are hardware analog ins that go to actual hardware functionality inside the PSOC.
So what does that mean? What sort of sensors, what sort of inputs are you going to be running into those analog in?
There are a lot of distance sensors that are analog report.
Absolutely.
There are a lot of position sensors that are analog report.
Yep. Light sensors, right? Photovoltaic resistors.
Light sensors, light-dependent resistors really are that way. And there are a lot of sensors like strain gauges and things like that after you condition them properly will give you an analog signal.
And any flick or flex sensors, those are all analog signal.
So there's a lot of value in having some uncommitted analog inputs.
Absolutely.
I've got a hardware I2C and a hardware SPI.
Fantastic. No,
as uncommitted.
What are
those are the for those of us that drink soda, okay? Those are the Coke and Pepsi of embedded serial protocols. Any chip that has a digital control, any sensor that has a digital control is a 90% chance that it's either I2C or it's going to be SPI. And it really, in the embedded systems world, that's like the 2 heavy players in that space.
Those are both communication protocols, correct? So they allow you to communicate with sensors with onboard ICs or with an entirely separate board if you wanted to run another board for machine vision or anything you could think of.
There are accelerometers.
Absolutely.
There are I2C. There are accelerometers that are SPI. There are inclination sensors, all sorts of things like that.
Yeah, actually, Seed Studios makes a great I2C sensor pack, which is really plug and play for beginners, and we'll be talking about that in a later video. But that's where you'd be connecting all of those sensors is to the committed I2C and SPI ports.
Yep, and I put an uncommitted UART.
Oh, fantastic. So for those of you who don't know, UART stands for Universal Asynchronous Receive Transmit. So that is another way that robots can talk to each other, and UART is the most generic that everything is based on. It is literally the bit stream you are sending.
And there is so much hardware out there.
Oh, absolutely.
Practically every piece of, practically every microcontroller you can buy today, practically every embedded development board you can do today, lots of sensors, lots of hardware made by, I would say, thousands of manufacturers.
Oh, absolutely everybody has UART functionality available for both send and receive.
And that's another place where you would want to use it. I've used it with Bluetooth. You can get Bluetooth. You can get Bluetooth dongles.
Yeah, which can talk to YouTube. You know, if you have a host computer set up.
But you can get Bluetooth dongles very inexpensively. You know, $7 or $8.
Yep.
And there are, again, thousands of devices that you can connect to an uncommitted UART. And this combination, what it really means is that if you want to do a project, if you want to do an experiment, if you want to try things, then chances are the bits and pieces you need to bring together to realize what you're trying to put together.
They're here. They're all here.
This isn't everything, but this provides an excellent base to connect to the everythings you need to make things happen. So if you need to run outboard, additional motors, you need to run a GPS, you need to run accelerometers, you need to run temperature sensors, or anything of that sort, the tools you need to talk to the additional hardware you want to bolt to the chassis is there. And because the chassis itself is open source, you take our cut files and you hack them up. And you make a cut file with a bracket for this weird sensor and a connection for this actuator, and you change this and you change the shape of that, and you end up with something that bears no earthly resemblance to what I built. And to be real honest, I'm looking forward to that. I think that's going to be wonderful.
Absolutely.
And one of the things that I'm really looking forward to see over the next year or so is as these get out into the wild and as people gain a little bit of experience hacking on the platform, I really expect to see some of the things that I've seen with Arduino, where someone will do something and then someone else will look at what he did and say, that's cool, but, and produce a mutated version of that. And then the third one, she says, well, his, but somehow different.
Absolutely.
Or
absolutely.
I'll flip it on its head. Or I don't like his aftershave, I'll do it different. I don't know. But the point is that by repeated mutation, you see some really incredible stuff come out of that community.
Absolutely.
And this is the kind of framework that makes that possible. And the other thing that makes it possible, I haven't really gotten into yet, is all the host side stuff, which is to say all of the software that runs on the Raspberry Pi side of this is 100% open source.
That's
all
fantastic.
the C code, all the drivers, all the Python code, all the graphic user interface code, 100% of the code for this that runs on the Raspberry Pi is open source. No binary blobs, no weirdness. It's 100% open source. If you can't get it to build, either I did something wrong and you shoot me an email and I'll fix it, or you're having a problem with your build environment, and to be honest with you, I'll probably help you fix it anyway.
Absolutely.
We're really going out of our way to make this platform as open as possible, because I really think that that's the only way forward for education.